and start talking through these. So if you're still finishing cutting and gluing, just try to listen up. I'll be honest with you, I think what we do this week, the second half of chapter 3, I think is a lot simpler than the first half of chapter 3. What we do today, the hardest thing of what we do today is going to be the proof that we do at the bottom of this. But what your homework is going to be today, hopefully is going to be pretty simple. So today we have a postulate and we have 2 theorems to introduce. So the first postulate is postulate 3.2. And it's called the parallel postulate. And it basically says if I have this line, and then I've got a point, okay? Through this point, there is exactly one line parallel to that line that I can draw, okay? No more, no less than exactly one line that I can draw parallel to this line, okay? Pretty simple idea, okay? The first theorem for today, theorem 311, I don't think is probably new information to you guys, but it's the triangle angle sum theorem. So it just basically says that the 3 angles in a triangle add to be 180, which, like I said, I probably have heard that before, maybe, maybe not. But anyway, in case you didn't know that, the angles in a triangle add to be 180. But the third theorem, or the second theorem, the third little tidbit here, is something that probably is new that maybe you didn't know before. But before we talk about that, we have some vocabulary because Theorem 312 mentions this vocabulary. So let's talk about this first. So when you have a triangle, you can have what's called an exterior angle. So you've got the interior angles, okay, like the ones on the inside. But if you were to extend one of the sides of the triangle, you create an exterior angle. So this is just one exterior angle that you can create. Okay, I could also extend that side, or I could extend that side. And actually, in fact, I could extend that side that way, or I could extend that side that way, or I could extend that side that way. So there's a lot of exterior angles that I can create. Okay, so for this example that we have here, the exterior angle is angle 1. Okay, it's on the outside, exterior, all right? Now, what we're going to be interested in is not only the exterior angles, but what are called the remote interior angles, okay? The remote interior angles. Anytime you have an exterior angle, there are always 2 remote interior angles. So the 2 remote interior angles are going to be the 2 non-adjacent angles. So remember, adjacent means next to. So if I have angle 1, the angle next to angle 1 is that one right here. That's not one of the remote interior angles, okay? The 2 remote interior angles are going to be these 2 right here, the non-adjacent interior angles. So the remote interior angles here would be angles 2 and angle 3. You know, the reason why we're interested in that is theorem 312, which is the triangle exterior angle theorem. So the triangle exterior angle theorem, which is really kind of interesting, I think, it says that if you were to take the measure of your exterior angle, so in this case, if you were to take the measure of angle 1, that is equal to the sum of the remote interior angles. So in this case, the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. So the exterior angle equals, the measure of that equals the sum of the 2 remote interior angles. Kind of interesting, okay? All right, so this is probably the hardest thing what we do today is this proof right here, but I'm not going to lie to you guys. Last night, whenever I was going through my notes, and I was copying down this proof, and I was kind of just copying it from the book, trying to develop it on my own, but kind of going off the book, and I'm just sitting here, like, going through the steps, and I'm like, where is this going? I'm not seeing it, and then, like, it clicked, and I was like, whoa, that's amazing! And it was like, mind-blowing, and I know the same thing's going to happen to you guys. Are you ready? Okay, we are going to prove Theorem 311. We're going to prove that the sum of the angles in a triangle equals 180. You ready? Okay. So our given, this time we're just given this triangle, okay? We are going to prove that the measure of angle A plus the measure of angle 2, we're going to rename, in the process of all of this, we're going to rename B2, plus the measure of angle C equals 180. Okay, so we're going to do a 2-column proof here. So with a 2-column proof, we have our column for our statements, a column for our reasons. All right, now, first thing I'm going to do to throw you for a loop, usually our first statement is the given, but this time my given is my triangle. Great. Not really going to need anything from that. It's not going to be really that useful. So the first thing we're going to actually do, what our first statement's going to be here is I'm actually going to add something to my diagram. Okay? So here's what we're going to do. My first statement, I am going to draw a line. Okay? I'm going to draw line PR. PR. I'm going to draw line PR. But I'm going to draw line PR through point B. Draw line PR through B parallel to segment AC. I'm going to draw a line through B that's parallel to segment AC. Now here's the thing. Here's my reason. How do I know that I'm able to draw a line parallel to AC through a point? Cuz. Why cuz? The parallel postulate. That was our new parallel postulate. That was our new postulate that we added today, right? The parallel postulate says through a point, okay, you can draw exactly one parallel line to AC. So let's go ahead and draw our line. So one line parallel to AC. Okay. Now we call this line PR. So it just means that on this line we have point P and we have point R. It's also going to be helpful if we can talk about these individual angles here. So let's go ahead and let's label angles 1, 2, and 3. Now notice, this helps me with my proof because I'm trying to prove that the measurement angle A plus the measurement angle 2, which notice is B. I have to talk about it as 2 because now I can't talk about angle B, right? Because angle B includes all of that stuff right there. That's why I'm calling it angle 2, and then plus measured angle C. Okay, with me so far? Okay, now, remember what I'm trying to do is I'm trying to show that if I add all three of these things together, I get 180. Not really sure where to start, so maybe we just start with this idea of 180, that we're hoping that we can prove that the sum of the measures of the triangle is 180. So maybe we start with this idea of something equals 180. Well, I know that a straight line is 180. So what I'm going to do is I'm going to start with that idea. Okay? So I'm going to start with, okay, this big angle right here plus this angle is a straight line, right? So let's go ahead and say that. Let's say that the measure, sorry, not the measure, let's say angle, now I need to name this angle. Remember, I can't name it angle 1 and 2. I can't name it angle B. I'm going to have to name it using the point. So P, B, C. Angle P, B, C, and angle 3 are supplementary. Do we agree on that? Angle PBC and angle 3 are supplementary. How do I know they're supplementary? They are a linear pair. They are a linear pair. Now, since they are supplementary, how can I take that a step further with that same idea? What does it mean if they're supplementary? They add to equal 180. So I can say, okay, well, the measure of angle PBC plus the measure of angle 3 equals 180. Great. How do I know the measure of angle PBC plus the measure of angle 3 equals 180? Yes, that's the definition of supplementary angles. Very good. Okay, now keep in mind what I'm trying to do is I'm trying to talk about the triangle. So I kind of need to start taking in the individual angles. So not like the big angle, I need to start talking about the individual angles. So what I'm going to do next is I'm going to break apart this angle PBC because I really want to talk about angle 2, right? So I'm going to break it apart. So what I'm going to do here is I'm going to say that the measure of angle PBC, okay, the measure of angle PBC, the whole thing is equal to the measure of angle 1 plus the measure of angle 2. So what I just said here, the measure of angle PBC equals the measure of angle 1 plus the measure of angle 2. How do I know that? And there's something in our flip book. I think. Now that's interesting. Not the one that I'm looking for. This is actually from like chapter 1. That I had this, I think it's a postulate. I had this postulate that says, okay, this little angle plus this little angle equals the big angle. Here's where we're doing that. Now you kind of, remember it? There we go. Angle, addition, postulate. That's why you guys have your flip books. I'm not expecting you guys to remember that stuff, okay? That's why we have that, okay? Okay, now, what I can do now, let me make sure, okay. So I now know that the measure of angle PBC is measure of angle 1 plus the measure of angle 2. Okay, so here's what I'm going to do next. Watch this. If this is the measure of angle PBC and this is the measure of angle PBC, what could I do here? Well, substitute it in, okay? Let's do the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 1/8. And I kind of already gave this one away, but how am I allowed to do that? Substitution. So this is the part whenever I was copying it out, I'm like, okay, cool. The measure of angle 1 plus 2 plus 3, it's a straight line. Of course it equals 180. Why do we need to do this? Okay? Keep in mind what I'm trying to do here is I'm trying to say, okay, 2 plus A plus C is 180, not 1 plus 2 plus 3. So what I need to do is instead of 1, I need to use A. And instead of 3, I need to use C. And this is where I was like, whoa, this is amazing! You ready? These are parallel lines, right? We established at the very beginning. If these are parallel lines, what could you say about angle 1 and angle A? They are congruent! How do we know that? Alternate interior angles. I know! Isn't that amazing? Angle 1 and angle A are congruent because they're parallel, they're alternate interior angles. And what about angle 3 and angle C? Yeah, they're also congruent! Oh my gosh, isn't that amazing? Okay, so let's write that down. I know! Isn't it amazing? Okay, so we said angle 1 is congruent to angle A, and angle 3 is congruent to angle C because they are alternate interior angles. And I can kind of take that one step further, and I can say, okay, since angle 1 is congruent to angle A, the measure of angle 1 equals the measure of angle A, and the measure of angle 3 equals the measure of angle C. How do I know that? I mean, congruent angles have the same measure, right? If you want to say definition of congruent angles, it's fine. What your book uses is it says congruent angles have the same measure. Okay, we're almost there, guys. We're almost there. Up here, we said angle 1 plus angle 2 plus angle 3 equals 180. I'm trying to prove that angle A plus 2 plus C equals 180. But here's the thing. Measure of angle 1 equals the measure of angle A. So guess what I can do? I can say the measure of angle A plus the measure of angle 2 plus the measure of angle C equals 180. Why am I allowed to do that? What did I do? And it was kind of from this step, using those 3 steps right there. I went from 1 plus 2 plus 3 to A plus 2 plus C. I substituted. So substitution property. And there's my proof! Woo! That was so fun! I'm telling you, like I was working this out last night and I was like, I did not see that coming. It was like a told us. He was at the fire station, so I did not. I might tell him tonight. I'll be real excited. Yeah. Anyway, alright, let's get this glued into your notebook. Page 41. This is 3-5 and parallel lines and triangles. Parallel lines and triangles. Alright, we are going to be drawing some pictures today, mostly triangles. Actually, I guess all triangles, so not too bad. First couple ones should be pretty easy. So talking about the interior angles of a triangle. So let's draw a handy little triangle here. Keep in mind that you can never assume that the drawings are drawn to scale. So no matter how much it may look like a right angle, or how much it may look like the angles are congruent, you cannot assume that. Unless they tell you that, you cannot assume that. So for this triangle, this angle right there is angle 1. That's what we're going to be looking for. This top angle is 92 degrees, and then the other angle is going to be 32. Now, what do I know about these 3 angles? They're not congruent. They add up to be 180. Okay? Well, if all 3 of these add up to be 180, well, I could add these together. 90 plus 32 would be 124. So if 2 of them are 124, how would I find the other one? 180 minus 124. That last angle is going to be 56. Okay, let's do one more of those. Okay, got this triangle here. Okay, this bottom left angle is going to be angle 1. That's what we're looking for. This top angle is going to be 40, and then the other one will be 32. And same idea, right? Even though the triangle looks different, I still know that all 3 of these add up to be 180. So if I add these together, I get 72. So to find the third one, 180 minus 72 is going to be 108 degrees. Okay, not too bad, right? Okay, so we're going to take that just maybe a step further. Maybe look at a little bit more, a picture with a little bit more to it. Okay, number 3. Okay, let's draw a big wide triangle like this. And then it's going to have a line coming down. Let's peek. Okay, for this left hand, oh, and then let's label the triangle. Sorry, A, B, with the right is going to be C, and then that point in the middle there is going to be D. Once again, I'm going to remind you again, you cannot assume anything is congruent. You cannot assume anything, right, is a right angle, anything like that. Okay, angle A is going to be 59. The left side of angle B is going to be 43. The right side of angle B is going to be 49. And angle D, the left side is going to be X, the right side is going to be Y, and then angle C is going to be Z. Okay, so I've got 3 things to find, X, Y, and Z. Which one can I find first? X, yeah, A, D, B, right? I can find X first by the exact same way we did the other 2, right? these three angles add up to be 180. 59 plus 43 should give me 92. Yeah. Not feeling super confident in my math today. Anyway, is that right? That's right. 59 plus, no. 102. Thank you. 102. That'd be better. Okay. So then to find angle X, exact same thing we did before. We would take 180 minus 102, which would give me 78. I gotta check my math. My brain's not really working today, so it's still in a 3-day break. Okay, so if we like to label this, if I know that that's 78, which one could I find next? Y. How are you going to find Y? It is BDC, that's correct. Those are just yelling out letters. Elijah? If you add up, if you did added what? 59 and 43. That's an interesting one to think about that. So he's using the exterior angle. Remember that it says the measure of this exterior angle equals those two added together? That would be an idea. Did you have a different way, Leo?
X and Y are linear pairs.
They're linear pairs. So you could also take 180 minus 78. Either way, guys, you still should get 102. Either way. If you take 180 minus 78, you get 102. If you take 59 plus 43, you get 102. And that way, awesome. Okay, so that's your Y. Now that I know Y is 102, how would I find Z?
BDC.
You're just yelling out letters. Okay, I need to find Z.
49 plus 102.
Okay.
And then take that from 180.
Okay, so 151, 49 plus 102 is 151. 180 minus 151 would give me 29, which gives me Z. Very good. Very good. Awesome. Okay, and then let's do this one where I've got kind of like a little fish, you know, like the Christian fish, but like a pointy fish. Kind of. Yeah. Okay, this top angle is going to be 65. The bottom one's going to be 50. That other angle is X. And then label that one Y. Okay, which one should I find first? X, by doing the exact same thing we've been doing, right? 50 plus 65 gives me 115. 180 minus 115 would give me 65. How are you going to find Y?
It's the same as
It's the same, right? How do you know it's the same? What's that word? Vertical. They are vertical angles, so they are both going to be 65. Okay. All right. Let's try. Now let's bring in those exterior angles. Okay. So we'll draw a triangle here. Look something like that. For this one, we want to find this exterior angle here. And that bottom left angle is 34. The top angle is 41. Now remind us, what do I know? What's the relationship between these three angles? Remember, to find the exterior angle, this equals the sum of the two remote interior. To find angle 1, you just add those together. 34 plus 41 gives you 75. That's all you have to do. That's all you have to do. The exterior angle equals the sum of the remote interior angles. Let's do one more of those. And we're almost done. Now this time, I'm going to give you the exterior angle. It's 112. This top angle here is 94, and I'm looking for the bottom right angle.
take 412 minus 1.
Right? I know that 94 plus this angle adds together to equal 112. So to solve that, we would take 112 minus 94, and we should get 18. Okay, questions on any of this so far? Okay, I got one more for you. And this one's going to seem kind of funky and kind of different, but your homework problems are going to be worded almost the exact same. So we want to use the given information to find the unknown angle measures in the triangle. So number 7, it's going to read like this. The ratio of angle measures in a right triangle are 2 to 3. The ratio of the angle measures in a right triangle are 2 to 3. Now let me help you make sense of this, okay? Got a right triangle, okay? I've got 3 angles in my right triangle. I know one of them. What's one of my angle measures? 90. Okay. I know that one's 90. So what I'm looking for is I'm looking for these 2 angle measures here. Okay? Now I don't know what they are. I do know that if I take this plus this, I get 90. I also know that the ratio of these 2 angle measures is 2 to 3. What this means, if you were to take this angle over this angle, so if you were to write them as a fraction and reduce them, you get 2/3. Okay, so to kind of throw out some options here, okay, if I were to reduce it, I'd get 2/3. So maybe they're 20 over 30. Or maybe it's 14 over 21. And you could do this. You could just keep writing them out if you wanted to. There's an easier way to do this, okay? No matter what the fraction is, okay, to get from 2/3 to 20 over 30, or 2/3 to 14 over 21, you're going to have to multiply 2 and 3 by the same number, right? That's what a ratio means. Well, I don't know what number it is, though, right? It could be 2 or 4 or 10 or 20. I'm not really sure what it is, but I know I'm going to multiply 2 and 3 by the same number. In math, whenever I don't know something, what do I use? In math, when we don't know something, what do we use? A variable! Oh my gosh, a variable! What is wrong with you guys? So if I write those angle measures as 2x over 3x, I'm going to take 2 and 3 and I'm going to multiply them by the same number. I don't know what that number is. So that angle is 2x and that angle is 3x. So to write this as an equation, if I were to add all 3 of these angles together, 2x plus 3x plus 90 equals 180. So 2x plus 3x is 5x. Plus 90 equals 180. Subtract the 90. We get 5x equals 90. Okay, divide by 5, you get x equals 18. Now, that's not either one of your angle measures. What am I going to do with that 18? Yeah. 2 times 18, 36. That's one of my angle measures. 3 times 18, which is 54, that's my other angle measure. Guess what? If you take 36 plus 54 plus 90, you know what you'll get?